Every company in the world is making decisions about humans using data that was never designed to understand them. Most AI today are in a race to replace them, capture their attention, predict their next thought, squeeze every last hour. But imagine what AI could do for the opposite reason. Current vision models can only describe what it sees, who moved where, and in what environment. They can't tell you if someone was drowning in stress, how the world feels around them, or whether they were just rotting. Entire regions of their brain dark without them even knowing. So we're not missing more data, we're missing the human. So that is why we built the layer that lets machines understand how to feel. So every construction manager, designer, healthcare worker can do their job with data designed for other people. Meta's Tribe V2 is a brain encoder. It predicts how 20K cortical regions respond to anything you see, hear, or read. So to make sense of all this data, let's go ahead and walk through the demo.
Hi everyone, my name is Johnny and I'm going to walk you through the quick demo of Amy, which is short for amygdala. The main reason why we want to build this is to be able to allow visual language models to see more than just actions and to basically feel the same emotions that people feel. So just to really quickly get into it, first the input source is a MP4. We have a couple of different examples here, but we're going to go ahead and start with a video of a cop. One of the first process is we do a vision analysis of this. This sends it through a basic vision language model. Then we send it to our unique tribe model, which is basically trying to map the video over to brainwaves or brain scans. And then finally we spawn in our K2 swarm. Each one of these specialists is an AI agent. And we basically try to simulate the interaction between all of these to process the gap between the actual summary over here, which was generated by the Quen model, and the emotional assessment, which was pre-cached from the tribe assessment. And so what these agents are now doing is iteratively refining itself. So they basically simulate a conversation between which parts are lining up more than others. And based on this sort of data, they basically try to align the content itself with the location of where the brain is so that we can basically feel the same emotions of what a person would feel while feeding an image where it's just doing pattern recognition of the data underlying from the content. So after we let the agents run for a little bit, we're just going to go ahead and go next. And at this point, we just have to wait for one longer process. It's basically collecting all the information that we have simulated from our K2 agents. Because of its fast inference, it's able to do 7 specialized agents to simulate between each other and to discuss and almost create its own conclusions from the content. And looks like we generate a final document. The score is the cosine similarity that we calculated from the brainwaves and the actual content itself. So this is what you would normally get from a vision report. Basically, it just describes what it is and what it sees. But with the empathy layer, we're able to actually see which parts of the brain spike because of the video content that it consumed. So we noticed that visual network climbed 2.67, which was higher than everything else, thus showing that we could track emotions depending on how it processes all this information. It also does it by timing, so we know throughout the whole process of the video what is going on. And finally, there's a falsification evidence. This is just for our self-improvement loop and the evaluation of that. And finally, we can ask about the brain trace. So this is how we actually uncovered the use cases of, for this scenario, we wanted to know how exactly the user was feeling during this altercation. So how was the user feeling during the altercation with the demonstrators? And so we use Opus 4.7 to fully process this and run it with the entire simulations of what the agents themselves came to the conclusion of. And now this is able to hopefully give us a analysis of kind of the entire environment. So in terms of use cases, this can be used to now give LLMs the ability to feel the same emotions that humans do, along with the data about what they're doing, what they're seeing, and now what people are feeling. Thank you.